Hi, welcome back. So here we have Jan 2020 question. The straight line L has equation y is equals to k into 2x minus 1. Where k is a constant, the curve C has equation y is equal to x square plus 2x plus 11. Find the set of values of k for which L does not cross or touch C. So when we have a parabola or a quadratic equation and a linear equation, there are three possibilities. So we have the quadratic curve, and if the line cuts the quadratic curve at two different points, then we know discriminant b square minus 4ac will be greater than 0. Suppose if we have a quadratic curve and then it touches the quadratic curve at one point, then we know the discriminant b square minus 4ac is equal to 0. Finally, the quadratic curve and the line, it's not touching or crossing the quadratic curve, then the discriminant b square minus 4ac should be less than 0. You need to understand that b square minus 4ac, the discriminant that we are considering, is of the resulting quadratic equation. Not this one, but the resulting quadratic equation. So how do we get this resulting quadratic equation? By equating the right hand sides. So this can be further expanded. K into 2x will give us 2kx minus k into 1 is k. So to find the point of intersection, we know that we need to make y the subject. Once we make y the subject, you take the right hand side, equate them. So x square plus 2x plus 11 is equal to 2kx minus k. Take all these terms from the right hand side to the left hand side. So x square plus 2x, 2kx, when it goes to the other side, it becomes minus 2kx plus 11, minus k goes to the other side, plus k. Now I can further simplify this, x square. Now if I take x common from this, I am left with 2 minus 2k. If I take x common from both of these terms, I am left with 2 minus 2k plus 11 plus k. Now this is the standard form. Okay, we can compare this with the standard form, that is ax square plus bx plus c. We have a as 1, b 2 minus 2k, and c is 11 plus k. This is the resulting quadratic equation that I was talking to you in the beginning. This is the resulting quadratic equation. Here only we can use b square minus 4ac less than 0. So we know, according to the question here, the discriminant should be less than 0. B is 2 minus 2k. So b square will be 2 minus 2k the whole square minus 4 into a is 1 and c is 11 plus k. It is less than 0. Now 2 minus 2k the whole square, we can expand the bracket. So 2 minus 2k the whole square means it is 2 minus 2k into 2 minus 2k. Let's expand the bracket or multiply the bracket here. 2 when you multiply by 2, you will get 4. 2 when you multiply by minus 2k, you will get minus 4k. Minus 2k multiplied by 2, you will get minus 4k again. And minus 2k into minus 2k is positive 4k square. I have like terms, minus 4k and minus 4k. I'm going to arrange this. First k square. So 4k square minus 4k is minus 8k plus 4. What I have here is just 2 minus 2k, this is what? 2 minus 2k, the whole square is what I got here when I expanded. So let's go back to this. So b square, that is 2 minus 2k, the whole square will be 4k square minus 8k plus 4 minus 4 into a into c. 4 into 1 is 4. 4 into, basically this is 4 into 11 plus k is less than 0. Now 4k square minus 8k plus 4 minus 4 into 11 is minus 44, and minus 4 into k is minus 4k less than 0. I'll get this as 4k square minus 8k minus 4k will give me minus 12k. 4 minus 44. 4 minus 44 is minus 40 less than 0. I can see that all of them, all the numbers are divisible by 4. So I'll divide the whole equation by 4. I'll get k square minus 3k minus 10 is less than 0. K square minus 3k minus 10. Two numbers multiply to give you minus 10 and add to give you minus 3. That is minus 5 and 2. Minus 5 and 2, when we multiply them, we'll get minus 10, and when we add them, we will get minus 3. So this will be k minus 5 into k plus 2 is less than 0. We need to find out the critical points or critical values here. Basically, equate them to 0. K minus 5, when you equate it to 0, we will get k is equals to 5. And k plus 2, when you equate it to 0, we will get k as minus 2. Now, we have to sketch the graph here. Coefficient of k square is positive. That means it will be a U shape. And it's cutting the x-axis at minus 2 and 5. So let's say this is minus 2 and this is 5 here. And then y-intercept is not necessary here in this case. So we just have to sketch the curve here. It's a U shape, so it passes through minus 2 and 5. And now check the inequality here. The inequality is less than. If the inequality is less than, that means the region which we have to consider is below the x-axis. Below the x-axis. So now, what are the x values that we have? X-axis values. What are the x-axis values that we have below the x-axis here from minus 2 to 5? So your k value will be greater than minus 2 and less than 5. So this is your possible values of k. K should be greater than minus 2 and k should be less than 5. The reason why I am considering the region below the x-axis is that the inequality is less than. If the inequality is greater than, then I have to consider the region above the x-axis. I hope you have understood this. Thank you for watching.